Hi, welcome to Chapter 1 of the Data Analysis course. I am your instructor. My name is Bhavishya Pandit, and today in this chapter we will be focusing on. So, here in the joining data frame section, right, for the people who do not know how joins work or what joins are, so it is important for us to understand joins first, right? So, basically, joins basically tells us about how do you want to merge a data frame. Now, let's say there are these two different sets, right? And you want to merge those data sets, right? But on what condition do you want to merge? On basis of that condition, the output of the merger would be like, right? So, and it also depends on how you merge it, right? So that basically is the condition. So there are different kinds of joins that we have in Pandas that are, right? So the first one is inner join. So we have this left table or the right table, right? Left table, right table, and similarly for the other two as well, right? So in this case, you can consider it as left table, left data frame. For right table, you can consider it as a right data frame, right? So over here, what does inner join basically does? It inner joins returns you all the records that have a matching values in both the tables, right? So let's say there are two different people, two different data sets, and for those two different data sets we want to understand how things are actually working. So in that case, what will happen is this Venn diagram supports things in that manner. So it supports right table, it supports left table, and then the column, the thing that is common would come out, right? And similarly for left outer join, what would happen is it would basically return you all those columns that are present, not only those columns that are present in both right and the left, but also all the columns, all the rows and the columns, all the values that are present in the left data frame. Similarly, the right join, how does right join works? It actually returns all those records, rows and columns that are not only present in left and right, but also it returns all the values that are there in the right join, right? Now comes the full outer join, right? Now how does full outer join is, it actually returns all the records when there is a match in either of them, right? Either left or right. If there is a match, if a match exists, it would show you the results, right? So if you remember, we have had read two data frames, right? So that is exactly for this purpose only we had read two data frames. So here we would be merging these two data frames to get a new data frame out of those two data frames, right? So we would be joining on this code, right? A common column between these two data frames is code. So if you see Mumbai underscore trains, we have this two station code over here, right? Which actually talks about the different codes of station, the different station codes that we have, right? So here the name of the column is two station code, but if you see for the stations data frame, the name of the column over there is R code, right? What does L suffix and R suffix means? L suffix means left suffix, R suffix means right suffix. And how does this left and right is being determined? Since this data frame is on the left side and station is on the right side, right? So stations would be considered as a right data frame. Mumbai underscore trains would be considered as a left data frame. Similarly, in this case, if you see it over here, right? So let's say in inner join, so this one is Mumbai trains, and this one is the stations data train, right? Stations data set, right? Basically. And L suffix supports for the left data frame, R suffix supports for the right data frame. And how do we want it to join? We want it to join in the left table because we are more interested in the trains data that we want to get, right? So that is exactly why we would do a left join order. And if you just run this cell, it shows us different columns out there, right? It shows us two station code, it shows us two station name, duration, h, number of hours, distance, code, right? Name, code, zone, and latitude, longitude as well. So Now we want to see the number of rows and columns that it has. So it has 12 columns now and 27 rows, right? Now there comes a very interesting fact, right? So there would be instances where when you are merging these two data frames, right? When you are merging these two data frames, there is a possibility that it would merge, but the entry would not be there because for a specific row, let's say a code exists in one data frame, but it does not exist in the other. I mean, the code exists for both of them, but a relative entry is not there, right? A corresponding entry to that specific station code does not exist in the other data frame, right? So when you'll merge the data frame, what will happen is it will show you a missing value. So here again, what that is exactly what missing value is, right? So if a missing value, I mean, if you want to understand a missing value basically occurs when there is no observation or there is no data recorded for that specific row, comma, column, a combination, right? And in terms of CSV file, if you see, it is often represented as NaN, which stands for not a number. Now, why is it important for us to treat a missing value? Why simply cannot we ignore it or cannot replace it with zero? Because zero is different from missing value, right? It would have been 100, 1000, but instead of 100 or 1000, if you're simply writing it as zero, the analysis can go very wrong, right? And similarly, if you are ignoring a missing value, then your analysis becomes more vulnerable to biases because there could have been anything out there in place of that missing value, right? But you simply chose to ignore it. So that would actually push your analysis into different biases, and you would not get the right results out of it, right? So there are ways of dealing with missing values, right? You can deal with missing values by dropping them, or you can fill them, right? But for now, we would focus only on dropping them because else it would be a digression from the main topic, right? Just an example of how missing values are. There is no value over here, right? There is no value over here. There is no value over here and here as well, right? So it shows a missing value over here. Like these over here also there is a missing value. So that is exactly what a missing value is, right? Now if I want to check that whether my data is having missing values or not, how do we find that, right? So for that we have a function is null dot sum, right? But let's say we'll just remove it dot sum over here and we'll just run it over here, and it would show you that there is no missing value over here. False, false, false. It shows missing value only when it has a true over here, right? So for this like for zone seventh row of zone shows missing value, and that is exactly how it is. But it is not very intuitive to understand, right? How do I make sense? It is not very intuitive, right? This true and false is not making any sense to me. I want a specific number of count. How many missing values do I really have? So to get a count, what we do is we basically do this sum, right? Which actually tells us what is the sum of the total missing values that we have. So for zone, state, and address, we have 11 missing values each, right? So as I said, one way of dealing with missing values is by dropping them. So we'll simply drop those missing values. So one way to drop them is by using drop NA function, right? So if you write drop NA function, it will simply drop all the missing values that are out there, right? There are different ways of different ways of dropping also. Like you can drop on the basis of threshold. Like you can drop you want to drop a specific row only when it has a specific number of, let's say if it has more than two columns of missing values only, then you want to drop it, right? Or there is one more way of if you want to drop a missing value, if you want to drop a row, even if it has only one missing value, you want to drop it, right? So it works like that also. So that works with the thresh parameter. So if you write thresh over here, and then if you write so it works on that. Now we'll just move forward and we'll try to understand how this thing works. Now coming forward to okay, I'll just try to show you it has been merged over here. We'll just make a new column over here and then we'll try to show it to you. If we write merge.df.head, it shows us all the columns, but I want to see whether the missing values have been dropped or not, right? So I'll just run it and it shows that all the missing values have been dropped, right? I want to now see the number of columns it has, right? So the best way again to do it is, as I had said earlier also, shape function helps us in that. So shape function, and it shows that we have only 16 rows now. 27 minus 11, 16. We have gotten 16. Now I want to see how many unique states I have, right? So I'll just run it and it shows me that there are 11 unique states. We have dropped all the columns, all the missing values, all the rows with missing values, and I now want to see the unique states that I have, right? So yeah, I've done it like that. Now I want to see how many unique states I have, right? Or I want to, here we have found how many unique states I have. Now I want to find how many total number of distinct values do I have, right? So for that, if I just use it dot n unique, so here we have used unique function, here I'm using n unique function, right? It shows us 8. One more way of doing it is you can simply use value counts for that, right? So value counts would actually give you the total number of counts for each and every each and every state, right? So but it does not show, it will not show you for unique values, right? It actually shows you the number of repetitions. So let's say in case of Rajasthan, it shows you that there are five repetitions are for Rajasthan. For Tamil Nadu there are 4 repetitions, and so on, right? And in a case where the total number of repetitions are very high, right? And there might be a case where simply showing numbers is not enough. So in that case, what we basically do is we basically plot a graph. So similarly, this dot value count function can actually be used for plotting a graph as well, right? So if you see, we have written the same query that we have written here, but now we have written dot plot, and now we are plotting a bar plot, right? So if I just run it over here, it will show me a bar plot over there, right? Now it has shown me a bar plot. So again, we see that for Rajasthan we have 5, for Tamil Nadu we have 4, for Uttar Pradesh we have 2, and so on and so forth, right? Here we are able to see and understand very distinctively because it is in sequence, right? 0, 1, 2, 3, 4, 5. It is integral, right? And we already know that these value exists, so it is very easy for us to determine. But in a case where the gap is much, right, and there are a lot of integers between these two numbers, let's say for example this is 500 and this is 400, like, and there is this one plot with in a plot it is showing somewhere between 500 and 400, right? So it is very important. We simply cannot say it is in somewhere between 500 400. We want to get a rough estimate of how where that thing might really belong, right? So in that case, grid function really helps us. So basically what it does is it plots a grid, and it then becomes easier to understand where that thing really is belonging to, right? Or it might give you a better estimation of making a statement where it might belong. So now again, that is exactly how this grid function works. Now again we'll be using this one query function to see the maximum distance that we have, right? And if you'll just run this, it more or less would tell us about the maximum distance that we want to see for a specific train, right? So it shows us for this Bandra terminus, to station code is J80, and the duration is 32 hours. So this train basically departs from Bandra terminus, and the station name is Jammu Tawi, and that is exactly how it goes. So now similarly, now we will try to use all the concepts that we have covered till now, right? it would be more or less like a revision. Here, like similarly, here we have had used for filtering the data, right? Now we would use the group by function to see the count of stations, right? So here it basically is giving the count of all the stations that are there, right? And this is one way of doing it. This is one way of doing it. It more or less tells us the number of stations that are there. If you remember, I already told you one way of doing it was with aggregated function, right? You could have done like that also. So here it shows for each and every column, it shows that each and every column represents the total number of times that specific state is being represented. As far as I remember, Uttar Pradesh is the largest state, so my hunch is that Uttar Pradesh might have the maximum number of stations. So let's try to find out which station has the maximum number of which state has the maximum number of stations. So for that, once again we'll have to reset the index. As I said, it more or less is a revision for the things that we have done and have covered in this chapter. So now if I just reset the index, the index has been resetted, right? And if you see, I have not dropped it. Had I dropped it, I wouldn't have gotten this state as a column state, right? If I would have used drop equals to 2, it would have been dropped, right? And the only thing I would have got was code name and all of that, right? Since the column name state is important to me, that is exactly why I have not dropped it. Here again, when we have grouped it by, right? When we have grouped by, the state has become the index, and now Andhra Pradesh acts as an index, Assam acts as an index, Bangladesh acts as an index, right? Now, as I said, I want to see which state has the maximum number of stations, right? There are multiple ways of doing it. So we'll focus on this one way of doing it. So if you see over here that we are using this one function called sort values, and we want to sort values by code, right? You can simply sort values by anything. And why code? Because that is an integral thing. I mean, that is more or less a distinct thing that we want, right? It could have been anything, right? I mean, in this case, what basically everything is integer, right? So it works like that. So ascending equals to false tells us that the condition is, it would show us in the descending order only. The default value of this attribute is true. So if I do not write ascending equals to false over here, and if I remove it completely, it would show me in the descending, it would show me in the ascending order, but I'm interested to see in descending order, right? So if I'll just run it again, it will show me, and again I've used dotted function to show me the top 5 of it, right? So it is showing me in descending order, like as I had said earlier also. Uttar Pradesh has the maximum number of stations, and that is 523, right? Now let's say, just for the sake of revision, I want to find out I want to find out what is the longest distance a train travels who departs from Uttar Pradesh, right? So for that, I'll have to use the train's data frame, and I'll again have to consider the station's data frame, and I'll consider from station code and the code again, right? And I'll just run it to get the data frame that I want. And now again, I want, as I've also written over here, I want to find the longest duration of the train that departs from UP, right? So now I'll filter the data set again, and I'll filter that I want to see only those trains who have state Uttar Pradesh, right? So now I've got these only those trains that have got state Uttar Pradesh, right? So again, I have 27 columns, and if I want to see the total number of trains that I have for that, right? So I'll just use df.shape again. It will show me the total number of trains that I have for that. So it shows that I have 5208 trains, and sorry, df underscore up up. Yeah, I was shocked. So yeah, it shows that we have 485 rows, 485 different rows which depart from 485 different trains that depart from UP, right? And since again there are 27 columns, there are a lot of that is a huge, right? That is a huge number of columns. If I want to see columns separately, right, I can again use dot columns functions, which would actually show me the all the columns that I have for that data frame, right? And now again, for the sake, I'll just there are a lot of data frames, right? I want my data frame to be clean. I want to see in a cleaner format, right? So again, I'll just use df underscore up, and I'll sort values by distance, and for specific columns only. Since I want to see the longest one, right? As I also said earlier, also I want to find the longest duration of the train that departs from UP. So here I've got I've got all the trains who depart from UP. Now I've got all the columns that are out there, right? And I want to focus only on a few data, only on few columns of the data frame, right? And again, I'm using dot sort values to find them in a descending order, and I would be focusing on a few columns only. And again, header function is being used to get the top 5 rows, right? And if I run it again, it shows that the maximum distance that a train travels from UP is 3,441 kilometers. That is huge. So that was it for today's chapter. In this chapter, okay, we are left with writing into the data frame, right? So now we have this data frame and I want to write it out, right? So how do we write it is df underscore up dot to underscore csv, and then we'll write the data frame. And how do we write it? We write the data frame by let's say we want to write UP trains by the name of UP trains, right? Dot CSV. And if I just run it up, it will save. So that is exactly how you save a data frame to a CSV, right? And if I run it, it has gotten saved. And if I just go to my home page and if I just try to see UP underscore trains, I would be able to find, see, UP underscore trains seconds ago, saved seconds ago, a few seconds ago. So that is exactly how we have done it. Last modified, it shows we have seconds ago. So yeah, that is exactly how you save a data frame into a CSV format, right? So in this chapter, we have seen how to read and write multiple files. We have understood and learned some different techniques of handling rows, columns, and indices. We have also seen query function to filter the data. We have learned about group by function, group by statement, and aggregated function. We also got to see joins, and also we got a good revision of the things that we have done till now, right? I really hope you learned something new from this chapter. See you again in the next chapter. Thank you very much.